Welcome back to the third in our series of videos on the Internet. We left off in the last one by hearing Dr. Leonard Kleinrock describe the earliest configuration of ARPANET. Let's continue. This is Dr. Vint Cerf. Dr. Cerf was a graduate student at UCLA when that first network was put together.
Okay, so I'm going to take you back 40 years ago. This was the original 4-node ARPANET. I was at UCLA at the time. Bob Kahn was at Bolt, Beranek, and Newman. I was around with other folks at UCLA receiving the Sigma 7 computer from what was then Scientific Data Systems. I think this was number 4 off the production line. That was the host that we put into the Network Measurement Center that Leonard Kleinrock ran. I wrote the software to connect the Sigma 7 to the first IMP, interface message processor of the ARPANET. Then a month later, in October, the SRI IMP was installed.
Thanks to Dr. Cerf and Stanford University for posting that to YouTube. At the time of that video, Dr. Cerf was associated with Google, so if they participated in posting this video, thanks to them also. How does all this work? If you think about it, the Internet is a really complicated thing. You have an incredible number of different devices made by different manufacturers in different countries, made and operated by people who speak different languages, all passing along data from different hosts, and it all works. It's amazing. So how can that be? It works because all of the equipment and the software is designed and manufactured according to established standards. In other words, there are rules about how each of these products function. How are those standards established? Take a look at this slide. In the upper left image, you see what appears to be an RJ11 connector. That is the connector that links the telephone, pictured here, to the port in the wall of your house. So the question is, how did that connector become the standard for connecting a telephone? You'll notice that all telephones have it, regardless of who makes them. It's an example of a standard that evolved because of the existence of a monopoly. Throughout most of the 20th century, AT&T held a monopoly on phone service in the United States through a network of companies called the Bell System. In order to avoid action from government antitrust suits, AT&T and the federal government entered into an agreement known as the Kingsbury Commitment. In the Kingsbury Commitment, AT&T and the government reached an agreement that allowed AT&T to continue operating as a monopoly. While AT&T periodically faced scrutiny from regulators, this state of affairs continued until the company's breakup in 1984. Much of that comes from Wikipedia. As a result of that monopoly, everything AT&T did, every design they created, became a default standard. The RJ11 is one of those standards. This example represents one of 3 ways that a technology becomes a standard that we will discuss. Manner number 1, this one. Some technology becomes a standard due to an organization's monopoly status. The lower image is of an old parallel interface connection for a printer. While this one is no longer used, it was the dominant method for connecting your computer to a printer for many years. It's called a Centronics parallel interface. In the 1970s and 80s, Centronics was a major manufacturer of printers, and their product was one of the most common found in the industry. This connector was their design for interfacing to a computer, and because of their popularity, it became the standard for parallel interface. So method number 2 of a product becoming a standard is that the product is so popular that its technology becomes the standard. In fact, you can probably make a case that the typical PC of today is based on the standards set by the original IBM PC because of its popularity. In fact, the term PC was first coined for that very machine. Finally, there are organizations in the business of establishing standards. Here are a few: the Institute of Electrical and Electronic Engineers, IEEE, the International Organization for Standardization, ISO, and many more. These organizations may be independent agents that work for the establishment of standards, or they may be associations of manufacturers who have gotten together for just that purpose. So this is the third way that we have discussed for establishing standards. That is, certain organizations exist for the purpose of establishing standards. So we've talked about three ways that standards evolve. First, a standard may evolve because the organization that created it had a monopoly. Secondly, a standard may evolve because a product was so popular that it became the standard in the industry. And third, a standard may evolve because an organization in the business of doing that created it. Here's another standardized technology. That is the RJ45 connector. Does it look familiar? It really looks like a larger version of that RJ11 that we saw earlier. Actually, it is. They are both Bell system designs. The RJ11 has 4 conductors, while this one has 8. This is a connector used on a twisted pair cable like the one you see here. That is the most common form of medium used on a local computer network called a local area network, or LAN. That 568B that you see on that RJ45, that's a standard for how those 8 wires are connected to the pins of this connector. White orange, orange. White green, blue. White blue, green. White brown, brown. That is actually called the EIA/TIA 568B standard because it was established by 2 of the agents on the previous slide, the Electronics Industries Alliance and the Telecommunications Industry Association. Let's take a break. Look over your notes, come back when you're ready, and we'll continue our series on the internet.